Thank you for coming. My name is Nitzan Shapira. I'm from Epsagon, originally from Tel Aviv. I am now based in New York. I'm going to talk about the cost of serverless in terms of money and some things that some people don't necessarily think about when they start and even as they progress in serverless. Few words about me. I live in New York for the last 2 months. I recently moved to the US. I'm a software engineer. My experience is in cybersecurity, embedded systems, and more. And for the last roughly 2.5 years, I'm one of the founders and the CEO of Epsagon, a company based in Israel and the US. So just a few words about what we do, just so you have context. We are pretty involved in the serverless community. We are developing a monitoring and troubleshooting platform for microservices, including Lambda, containers, and so on. So everything from end-to-end visibility, tracing, to help engineers and DevOps troubleshoot issues much faster. So when you think about serverless, many people explain it in different ways. And some of the things that come to mind is also the less payment, less money. You don't have to pay for what you don't use. It's like a big deal. Yeah, that's how AWS is marketing it in many cases, which is true. I mean, we're using serverless 99% of we have thousands of Lambda functions, and our bill is pretty high actually. But I mean, for the Lambdas themselves, we don't pay that much. So there are a lot of advantages. It's true. But overall, I mean, besides pay-per-use, which is a great thing, the main advantages that we're seeing is the scaling. So basically, the cloud provider will take care of the scaling. And as your traffic goes up and down, you can be up and running without worrying too much, at least in theory, if it's designed very well. And the actual big advantage is the developer velocity, because you can ship much faster when you don't have to worry about the underlying layers. And we are actually doing it. We're shipping to production many times a day. Because we are 99% serverless, we don't have to handle almost anything but our own business application. And let's talk about pay-per-use. So what is really pay-per-use? It's just a phrase. Most people like it. It sounds good. I mean, you want to pay only for what you use. Nobody likes to pay for random things. The idea is that if you don't use, you don't pay, right? In reality, there is no way that you have an app in the cloud in production and you will pay zero, because even if it's not running, you're paying for something, right? For storage, for database. But at least for some parts, you can pay zero. And what is use? What are you actually using? So you can think, you want to use the resource and to get value out of it, but the pricing is dependent on some kind of formula. If it's time, if it's compute, if it's storage, or even number of calls and data. So use is a pretty abstract word, and it's very different from different services. So let's take a few examples. And you can already see that it's not that simple. So Lambda is gigabytes per second. What does that even mean? I mean, it's pretty complicated just to understand what that means. API gateway is requests and data. DynamoDB is also some kind of combination. So it's pay-per-use, but what is it really? So if you go into even the official explanations, you can see some simple formula that shows you how much you're going to pay for different use cases of Lambda. Very easy, of course, to understand. And API gateway, again, I mean, some kind of math that you're supposed to do to get to the point where you can actually estimate. And DynamoDB is my favorite. It's a basic example. So that's how you know exactly how much you're going to pay at the end of the month. So, I mean, it's pay-per-use, but you have no idea like how much you're going to pay. So that's already a pretty big challenge, either if you are a small company that has limited budget, so you have to know, right, so you won't run out of money. Or if you are a huge company with very specific budget, so again, you can't just say, I don't know how much this is going to be. So that's a big problem, actually. Yeah, it's kind of a, this is simpler than understanding DynamoDB, probably. So, right, I mean, but if you want to use those services, usually the whole point is that you don't want to go and do all the math because you're going to waste more time on that than actually setting up a server. So you want to be up and running quickly, and you're kind of counting on the cloud provider that the math is solid in a way that you will actually pay for some reasonable amount, but as long as you're not making any mistakes, of course, because AWS is not responsible for your architecture problems. So, but just to make it basic, serverless basically means that you want to pay for the performance, you want to pay for what you actually use, and in Lambda specific, it's basically time, how much time the Lambda is running. That's how much you're going to pay, because you are assuming that while the Lambda is running, it's doing something meaningful for you. You wrote it, right? So it makes sense to pay for the time of the Lambda. Now I'm going to share a life story of me, actually. So I was sending this message to our CTO. This was 2 years ago when we just started the product. So this is in Hebrew. I'm sorry for the language. But basically, I saw sending the screenshot of Epsagon monitoring our own instance of Epsagon. And I say in Hebrew, is this for real? And what I saw over there was one of the features that we had back then, we still have it, is estimation of the cost of the Lambda function. So according to the, let's say, week that has been, we are estimating that the month will be this much. We just multiply it, not something fancy. But then I saw that one of the functions, just one Lambda function, was expected to cost over $12,000 per month. We were a seed-funded startup. This is not like the best way to spend our money, to close shop early. But I saw it, and I was sure it's some kind of a bug, because obviously we can't be paying $12,000 for one Lambda function. And I told him, is this for real? And he looked, and it was actually not a bug. And then I was like this. So it was really, the reality was that we did have a function that was about to cost this much money. And it just didn't make sense. I mean, we are not even such a high scale. I think we had 20 or 30 companies using Epsagon. Back then, it was not a big deal. So why did it actually happen? It was not because Lambda had a bug. It's because we had a problem in our architecture. And this can really happen to, I believe, many companies. So what we did, it was a feature that we still do today. We basically generate metrics on Lambda functions based on CloudWatch logs. We know how to analyze the last line in the log, and then we understand if it failed, if it timed out, something, and so on. So back then, what we were doing, we were doing the trivial thing. We were essentially launching an MVP, and the MVP became the product. So the MVP was that every function of the customer, we have our own function that will query the logs every few minutes. And we didn't think about how many functions the customer will have. So when they have 10 or 100 or 200, it was OK. Suddenly, we started to have a customer with thousands of functions. And it was like a fan-out pattern. So we were running them in concurrent. And every time we read something from the CloudWatch, we were trying to save it to an RDS database. And the problem is that the Lambda scales pretty nicely, but the database did not scale that way. And what happened is that, yeah, that's what you say probably when you see this kind of thing, such a bad architecture. But think about, if you have thousands of functions and you need to architect something, it's very likely that you will not take into account the behavior of all the elements. So what happened is we got to a point where we had 10 concurrent Lambda functions. They were timing out constantly. The database was nothing actually worked also. The metrics were not generated. So this was like failing as well, but everything was throttling and timing out, and this led to this behavior. And the problem was that we didn't think about the behavior of the APIs together with the Lambda. So this is something that, again, the architecture has to be very suitable to be able to scale if you're doing pay-per-use. Otherwise, you're going to pay for bugs or for even design problems, which are more complicated than bugs. And the elegant solution to the problem, which is what we do today, is instead of pulling, we are subscribing the logs of CloudWatch, and they go directly to a Kinesis, which handles them in bulks. And now we are dealing many orders of magnitude more than we did before with no problem, because this is a a scalable way to build it. But again, maybe you even have parts in your system that will not scale, or will not scale at least on the cost manner. So this is just one example. Another common thing is that, again, as we mentioned, the Lambda is priced by time. So when you think about running time, you think about, OK, this is my Lambda. I should pay for it. But what are you actually paying for? What is the Lambda actually doing? So it can do things that are good for your business. Maybe it's some kind of a logic that you implemented in the code. But what about all those API calls? So today, in every app in the cloud, you will use many APIs, sometimes a huge number of APIs, both inside the cloud provider or outside the cloud provider. So that's one of the key reasons to go. Like, if you go serverless, you want to utilize APIs too, because otherwise you will still have to manage something. But what happens is that those APIs are out of your control. And especially those that are not in the cloud provider ecosystem can behave in different ways that you have no control over, and usually you are also not monitoring at all. And we have a simple example of a business transaction that it involves Auth0, Twilio, SNS, DynamoDB. Everything looks fine. It takes, let's say it takes 1 second to complete, roughly. But if you look closely, you see that this API to Auth0 is 700 milliseconds. So it's about 70, 80% of the time that you're waiting and paying for waiting for this API call. Basically, I mean, if this is running 1 billion times a day and your bill is $1,000, so probably $700 out of it is just waiting for Auth0. So what's the solution? So the solution is, first of all, to be aware of it and to know, if you have those bottlenecks. So if in the past maybe this was not a big performance problem, maybe this is not like a real-time service and the performance is fine, but on a cost perspective, maybe this is not good for you. Maybe you are actually paying, you can save 80% of the cost if you pay closely. And the solution here, for example, would be to reconfigure Auth0 to be in the right parameters, right region, or to use another service if it doesn't work for you. But when you use so many APIs, we have many statistics in Epsagon to show what APIs customers are using. And in many cases, an API can take multiple seconds to respond because you never know. Like, it's some API somewhere. Maybe it's like even a proprietary something that another team in the company wrote. And then at the end of the day, you're going to pay for every millisecond of those API calls. So it's not an easy thing to solve, actually. And in many cases, Lambda is just a very inefficient way to run this piece of code. That's really the reality. So the last thing that impacts the price of the Lambda is the parameters. So you need to choose memory. And many people don't really know how to choose memory. It also, and some people don't know that it also sets the CPU at the same time. So how do you know what to choose? Honestly, you don't know. Nobody knows. You just pick a default value and you go with it. And so we did some benchmark to understand what's the best way to pick them. And we basically played with the memory and saw how the Lambda ran faster. So in theory, you would expect that there will be some linear ratio between them. So you will pay the exact amount, whatever. But that's not the reality. And the reality is that, first of all, after some point, it doesn't make sense to get more memory because, like, if you don't need it, you're just going to pay for it. The Lambda will not run faster because the CPU, you don't need so much CPU. So in this case, it's roughly after 512 megabytes, it starts to not be linear anymore. And another interesting thing is to look at how much you're actually paying. And we found out that in some cases, you will pay the same for 2 different sets of performance of parameters. So in this case, if you pick 512, you will pay the same as 256, which is obviously you would want to pick the 512 because, I mean, you will get more memory. So it's pretty tricky, and most people, that's not where they spend their time optimizing. And I think that's actually right because it's too difficult to optimize that. If you have thousands of Lambda functions, it just doesn't make sense to spend so much time going over them again and again, and it's better to focus on the bigger picture and the architecture and so on. If you want to try it yourself, we have released this open source, so you can run it on your own Lambdas. And no, it's actually not on your own Lambda. It's just the test. But you can play with the code, for example. So this is a Fibonacci series code, so you can put some other code to see how it behaves. And just to summarize, there are cases that serverless is probably not the way to go. If you need something very high performant, sub-milliseconds and so on. So we have thousands of Lambda functions, but we have a core part of our backend, which is where we collect the traces in many billions of traces per day. It's not serverless, like the actual collector, because we need to be very, very fast, because otherwise it will impact the performance of the user. But other than that, everything else is serverless. And the cost is, again, if you are sensitive about the cost of a particular service or in general, just sometimes you should say, OK, I can't have the risk that this thing will cost me $20K a month, where all the rest is $2,000 a month. You just need to think about it in advance and be aware of it. And finally, again, we do think serverless is great, and we always choose to do something serverless, even if it's more complicated to architect, because then the developers are working faster. They deploy faster. And yeah, every once in a while, you need to think and you need to change. But this keeps things more modern and more efficient, and that way everyone is always just focusing on their business application and architecture and not handling with machines and servers. And pay-per-use, again, it's almost impossible to actually estimate how much you're going to pay. But the good thing is that Lambda is a cheap service. If you do the simple math, it's cost efficient. It's much cheaper than running EC2 if you don't need something strong. What's missing is the time you have to spend architecting something that's actually going to work. And yeah, make sure to monitor to track performance and cost so you won't have any surprises at the end. Thank you.